Okay, let's go over these homework questions from the sheet. So on the front side, which pair of concurrent forces may produce a resultant of 20 newtons? So yesterday we said you can get the maximum possible resultant if you add them, the minimum possible resultant if you subtract them, and then any force that this pair can create then has to be between the maximum and the minimum. So for A, the maximum will be 15 newtons, the minimum will be 5 newtons, and 20 doesn't fall between these two. So this one is not an option. This one, 20 and 20, the maximum is 40 newtons, the minimum is 0 newtons. 20 does land in here, so this one's possible. This guy, maximum 25, that's maximum 70 newtons. I thought that was 5, not 50. And minimum 30. 20 doesn't fall in there. This one's not possible. And this one, 35 newtons is max, 25 newtons is min, 20 doesn't fall in there. So the only one that's possible is choice B. Number 2, a resultant of a 7 newton force and a 12 newton force is 5 newtons. What must the angle between them be? So your F1 is 7 newtons. Your F2 is 12 newtons, and it's telling you your F net is 5 newtons. Well, the only way you can get 5 newtons out of that is if one is going one way and the other exactly opposite. So the angle between them must be 180 degrees. Okay, number 3, F1 is 30 newtons, and F2 is 30 newtons. And it's telling us our resultant, our F net, is 60 newtons. And so obviously these two must be going in the same direction. So the angle between them would be 0 degrees. Oh, maybe I'll do it over here. Number 4 says, which vector best represents the resultant force? So you have an F1 out like this, and an F2 down like this, and it wants the resultant. But remember, to get the resultant, you have to draw them head to tail. So you have to move F2. So that its tail, you're going to slide it so that its tail is going to be on the head of F1. And then the resultant starts where the first one starts, ends where the last one ends. So its resultant is going to look like that, which in your choices has to be C. So the answer for 4 is C. Number 5, which pair of concurrent forces which force could act concurrently with K? So this time K is going like this, and it wants to produce L. So L's your resultant. Okay? And so which one of these do you need to add to K to get L? It would have to be the guy going like this, which is choice B. So that when they're head to tail, they'll produce L. Okay? So that's the front side. The back side. Determine the resultant or net force exerted on a stationary element by 2 clowns pulling on ropes at right angles to each other, with forces of 400 and 300 newtons respectively. So it doesn't say direction. It just says, my elephant. It just says at right angles. Yeah, I can't draw the bottom part, so I'm going to leave it. So, because I don't have any room on the top, let's put our 400 Newton force down here. At right angles, we'll put our 300 Newton force this way. Could be any way. It could be backwards and up. It could be in the opposite direction. But remember, to add them, they need to be head to tail. So you either need to move your 300 Newton force down, or your, whoops, imagine that's perpendicular, your 400 Newton force over, and then your resultant will be where the first one starts, where the last one ends. Square them, add them together, take the square root. Hopefully you recognize this as a 3, 4, 5 triangle, so this should be 500 newtons. And then you need to find the angle. If you went this way, it would be that guy. This way, it would be this one. Do inverse tan. 400 over 300 is 53.13. 300 over 400 is 36.87. So over here you could say at either 53.13 degrees WRT with respect to the 300 Newton, or at 36.87 WRT the 400 Newton force. So with respect to, meaning measuring off the 300 down to the hypotenuse, it's 53.13. Measuring off the 400 over to the hypotenuse, it's 36.87. So that's all that means. But don't worry, I'll give you better directions like north, south, east, west when it really matters. All right, number 2. Number 2 says, 3 ropes pulled down on a weight scale that is suspended from the ceiling. So this weight scale suspended from the ceiling could be the one that's hanging there between the front 2 desks, okay, with the string hanging down. So it's saying if you have 3 ropes, and it's saying the one in the middle is 200 newtons. And then there's 2 acting out at angles, this way and this way. And they're also both 200 newtons that you're putting on these. And it's saying the angle here is 30 degrees. And it wants to know, what's the scale going to read? Well, the scale has to be providing equilibrium force. It has to read the force that it needs to put upward to balance out these 3 pulling down. Now the 3 pulling down aren't all acting straight down. The guys at an angle only have a component acting down. My pen is very dark. Only have a component acting down and a component acting over. So we want, this would be the y component acting down. That would be adding to the scale. And the x components, fx and fx, they're just going to be equal and opposite. And hopefully you see that, because if you draw them with the arrows, they're going in opposite directions. And they're going to be equal because the hypotenuse is the same, 200 newtons, and the angle is the same, 30 degrees. So if you found, if we called this one number 1, if we found f1x, we would use sine, and it would be sine theta is equal to f1x over f1. So f1x is going to equal f1, which is 200 newtons, sine of 30. And so that's just going to be 100 newtons, in this case going to the right. If we did f2x, it would be 100 newtons, but going to the left, it would be exactly the same math. So we can ignore the x's because they're not going to affect the scale. It's the y's that are. So we need to find f1y. And if x was cosine, x sine, then y should be sine because it's the adjacent side. So sine theta will equal f1y over f1. So f1y will equal 200 newtons cos of 30. Cos of 30 is 0.866 times 200. So f1y should be times 30 cos should be 173.2 newtons. And so to get the net force acting down, so in the y direction, it would be this 173.2 newtons from F1, plus the 200 newtons from the middle guy because he's acting straight down, plus the 173.2 newtons from The third one